Okay, so this is the brain where you can see that the brain is separated in two hemispheres. This is the right hemisphere. This is the left hemisphere. Okay, and they're going to separate through this middle groove right here called the longitudinal fissure. Regardless of the hemisphere that you're looking at, you can see here that the brain is going to have elevations and grooves. The elevations right here, for example, this right there, that's going to be a gyra, and the grooves, this one right here in dark brown, those are going to be sulcus. So your brain, as you can see here, is going to gyra, sulcus, gyra, sulcus, gyra, sulcus everywhere. Inside your brain, you may think that your entire brain is made of neurons, but no, there are spaces in there. These spaces are going to be filled with the cerebrospinal fluid. The spaces the fluid occupies is being shown to you right here in green. So then these spaces right here are going to be the ventricles. They are going to be occupied by the cerebrospinal fluid. These ventricles, we're going to have two of them on the side, so therefore this is lateral ventricle. We have two of them. So we have already two in there, then we have one more in here, which is going to be the third ventricle, and this is going to be the fourth ventricle. The fluid is going to be produced in the choroid plexus because in there we're going to have the ependymal cells. Now we're going to have in there interventricular foramens that are going to communicate the lateral ventricles with a third ventricle. And then we're going to have the cerebral aqueduct that communicates the third ventricle with the fourth ventricle. And from here, you can see down here, the central canal that will take the fluid from your brain into your spinal cord. We scroll down right here. We can see the elevations and grooves again, sulcus and gyras. Not only that, but the brain can also, based on the functions that the brain is going to have, they can be divided in lobes. Okay, so then as you can see in there, the brain can not only be divided into hemispheres, right and left hemisphere, but we can also divide it in lobes: frontal lobe, parietal lobe, occipital lobe, and temporal lobe. Now, if we cut the brain like that, then what we are going to see is this, where you can clearly see in this figure the cavities that we have right there, right? That one and this one, that's going to be the lateral ventricles, probably around there. Not only that, you can clearly see here as well the longitudinal fissure that separates this going the right hemisphere and the left hemisphere. We keep moving right here. We have the main areas in our brain. This part right here is going to be the cerebrum. This part right here is going to be the cerebellum. This is going to be the brainstem. And this part right here, the diencephalon. The brainstem is going to have three divisions. The top part right here, the midbrain. This one is going to be the pons, and this bottom part right here is going to be the medulla oblongata. After the medulla oblongata, what we have right here is the spinal cord. The cerebrum can be divided in lobes. This one is the frontal lobe, parietal lobe, occipital lobe. This is the cerebellum. The cerebellum can also be divided into hemispheres, right and left hemisphere. And we have right here, this is the diencephalon. The diencephalon is going to be in three areas: the top, epithalamus, the middle, thalamus, and the bottom, hypothalamus. Okay, so those are the main areas that you have in your brain. As you know, our brain controls everything. Right? Your cerebrum, for example, is going to make you feel and think and move. But for example, the cerebellum is going to coordinate the timing of your movement. Okay, so then, yes, you can move, but the coordination of that movement is going to be done obviously by this. In this area right here in your brainstem, you're going to coordinate how your heart beats, right? You're going to have in there cardiovascular centers. You're going to regulate in there how you're going to breathe. You're going to breathe, your breathing is going to be shallow or deep, right? Then that is going to be coordinated right there in the brainstem as well, right? Whether you have high blood pressure or low blood pressure, then that's going to be controlled right here as well in your brainstem. Right here, we said this part right there is going to be the diencephalon. In there, you control, for example, all your hormones. All the hormones that you have in your body are controlled by the hypothalamus, which is part of your diencephalon right here. So then if we scroll down right here, you have the same thing that I just showed you before. This part right here is the cerebrum. This part right here is the diencephalon. This part right here is the cerebellum. This one is the brainstem right there. This is a model, same thing, right? Right here you have cerebrum, cerebellum, brainstem, diencephalon right there in the middle. Well, I already mentioned the hypothalamus. I told you this is very important. That's part of the diencephalon, controls all the hormones that we have. Epithalamus is going to help us with the circadian rhythm because we're going to produce melatonin in there. That's basically the cycle that tells us, it's day and night cycle every day that we go through, right? That's going to be controlled by the melatonin right here. Okay, well, right here it says, right, to help us regulate that sleep and wake cycle. We scroll down right here. I already talked about the cerebellum. I mentioned this helps us, for example, with motor coordination and equilibrium. So I talk about the brainstem. I told you it has 3 areas. It's going to have midbrain, pons, and medulla oblongata, and they're going to have different functions, obviously, depending on the areas that we're going to be talking about. I mentioned that the brainstem is related, for example, with the cardiovascular centers and respiratory centers to help us control how our heart is going to beat and how our breathing is going to be. So after that, we have protections to our brain. We said that we are going to protect our brain with the meninges. We have 3 meninges: dura mater, pia mater, and arachnoid mater. Right here, you have a figure about the brainstem. Right here, this is the midbrain, this is the pons, and this is the medulla oblongata. The top part right here, this is the diencephalon, the one in blue. So we scroll down right here. We can see right here the protections that we're going to have in our brain. We said we're going to be protecting our brain with the meninges. We said dura mater, pia mater, and arachnoid mater. We also have a fluid in there. We said it's cerebrospinal fluid. And the fluid is right here, right? And the meninges, and obviously the bones as well, right? That's going to form the skull. Now, in addition to that, we're going to have structures called, areas called falx cerebri, falx cerebelli, and tentorium cerebelli. Meninges don't go like this, like that. Now, they're going to have some invagination, right? So right here, if you look at this, we say right here, we have the longitudinal fissure, right? The separate urohemispheres, right? So then this will go right here like this, and it will go right here, and it will go inside like this. So that is the falx cerebri right there. So this one, when it enters right here. So let me see if I can show you that better. Right here. So then you have your meninge that goes like this, right? And the falx cerebri will go like this, like that, and then there. That would be the falx cerebri right there. Okay, then we have falx cerebelli. This is your cerebellum, like this. The meninges will go in here like this, will protect right here, but they will enter right here like that. So then that is called the falx cerebelli. Then you have the tentorium cerebelli, which is this. So it will go, the meninges will go like this, and it will separate your cerebrum from your cerebrum. So it will go like this, like that. Right. So then this one, the tentorium cerebelli right there, that one. Right here, ventricles, and we said those are the areas where the fluid is going to go through. Now, the ventricles are going to be produced right here in number 1, which is where the choroid plexus is, right here. So we produce the fluid, and it will go down right here to the central canal, down into your spinal cord. It will go on the outside like this. Okay, and it will exit your brain through the arachnoid granulations, which are going to be these ones and these ones, right? Those are going to be the arachnoid granulations. So the fluid can come out of that through the arachnoid granulations into your veins. Okay, now that's necessary because we produce more or less 500 milliliters of cerebrospinal fluid, out of which 150 milliliters remain in your brain. Therefore, we are going to get rid of 350 milliliters through the arachnoid granulations. So if we scroll down right here, now we're going to go to the peripheral nervous system. In this case, what part of the peripheral nervous system? We're going to go to the autonomic nervous system. This is your body like this, like that. This is your spinal cord, and this is your brain. Right, so therefore, the nerves that come out of your spinal cord are going to be spinal nerves. So the nerves in your neck are going to form the cervical plexus. The bottom part of your neck is going to form the brachial plexus. Then we said right here, we're going to have the lumbar plexus. At the bottom, we're going to have the sacral plexus. The nerves on your spinal cord, but the ones that are in the middle, the ones that are going to be in your thorax, these ones in black right there, they're going to be called thoracic nerves. And they're going to be like that because they're going to be helping us with some other important functions in here, which are going to be regulate, for example, your heart, your lungs, your stomach, your intestines. So then these nerves in black are going to be part of the autonomic nervous system. So the autonomic nervous system is going to have 2 divisions. Sympathetic and parasympathetic division. So if we talk about the heart, for example, so then obviously we have the heart around here. Right? The heart is going to be around here like that, more or less. So these nerves right here are going to help you control the heart. The heart beats 70 times per minute, approximately. So then the heart is voluntary? No, it's involuntary. So therefore, what type of organ is the heart? The heart is going to be an automatic organ. So since you need to control an automatic organ, then you need autonomic nervous system. So the autonomic nervous system is going to be for an autonomic organ. So then what does that mean? Well, that means that this heart, right, the heart beats by itself 70 times per minute. Now, can we make this heart beat faster or slower? Yes. So then if we want to make this heart beat faster, then we're going to use the sympathetic nervous system, and the sympathetic nervous system will accelerate the speed of your heart maybe to, I don't know, let's say to 100 times per minute. Do you want to slow down your heart? Yes. So your brain can also do that and can slow down your heart. Maybe instead of 70, maybe it can go down to 60 times per minute. That is going to be controlled by the parasympathetic nervous system. So in general, right, most of the activities that your heart is going to perform, that your body is going to perform, that are going to be automatic, right, that's going to be controlled with the autonomic nervous system. So for example, you have blood pressure. Yes. Can you go higher or lower? Yes. So therefore, you're going to control that with the autonomic nervous system. So in general, sympathetic is going to be plus. And in general, parasympathetic is going to be minus. What do I mean by that? Well, for example, in the case of the heart, we talk about the heart. What does plus mean? I mean, in the case of the heart, what does plus means? Plus is going to mean, faster. But minus is going to be slower. Let's think about blood pressure again. So then what is it the plus means? Well, that's going to be higher. But minus is going to be lower. Your gallbladder, right? Your gallbladder produces bile. So then what does plus means? Well, plus means probably more bile. What does minus means? Well, it's going to be less bile. As you can see that the reason why I'm saying that sympathetic is plus, because it depends on what the organ is you're going to be talking about, right? So then, for example, the heart, it said plus means faster, or it may mean higher, can mean more, depending on the organ, right? But it can be a slower, lower, less, depending on what you're doing. Right? So therefore, what is it that the sympathetic does? Faster, higher, more. What is it that the parasympathetic is going to do? It's lower, lower, less,